Hello, I'm Alias at Costi. I'm here with the 5th session of the LSPLC training. In this session, we're going to get more familiar with how to address the internal memory of the PLC as well as with data structures. Alright, the first part is getting to know how to address the internal memory. In the previous lesson, we got familiar with the different types of addressing for digital inputs and outputs of the LSPLC. Now today, we want to get to know how to address the internal memory of the LSPLC as well. We represent the internal memory of the LSPLC with BEM. If we use MX, MX represents a single bit of memory. If we use MB, it stands for M byte, meaning we want to assign a value to 1 byte of the PLC's memory. If we use MW, we mean word. That is, we want to assign a value to 16 bits of memory. And if we use MD, we mean double word. That is, we want to assign a value to 32 bits of the PLC's memory. So, either 32 bits or 2 words. And finally, ML, which stands for long word, means 64 bits of PLC memory, or 2 double words, or 4 words. So, for bit memories, as we said, we use MX. For example, MX1 means bit 1 of the PLC's memory. Or for MB, which we said is for 1 byte of memory, for example, we can say MB10, meaning we assign a value to byte 10 of the PLC's memory. Or for MW, which we said is related to word memories. For example, we can say MW100, meaning we assign a value to word number 100 of the PLC's internal memory. Or for MD, which is double word, for example, we can say MD20. For instance, we assign a value to double word number 20 of the PLC's internal memory. And finally, long word, which we said is shown with ML, for example ML0, meaning we want to assign a value to the first 64 bits of the PLC's internal memory. So, these are actually direct addressing methods that we can use in the S7 PLC. Alright, the second part of today's discussion is about data structures. Data structures are a really important topic in PLC programming. And those who want to become professional programmers definitely need to be thoroughly familiar with these data structures. So, we can divide data structures into several categories. First, there are numeric data types. Second, there are bit-type data, which are logical. Third, there are date-related data types. Fourth, there are time-related data types, which deal with time. And fifth, the last one, string data type. Now, we want to get more familiar with each of these data types. We can divide numeric data itself into 2 categories. One is an integer type, which we commonly refer to as integer, and the second is real, specifically meaning decimal data, that is, numerical data that inherently possess a decimal point. Now, we can further divide integer data into several categories. Data types include short integer, unsigned short integer, integer, unsigned integer, double integer, unsigned double integer, long integer, and finally unsigned long integer. We'll get to know each of these data types in more detail as we go on. So, what we mean by unsigned in some of these data types is that our data is without a sign. That means our data is positive. But data types that don't have been signed, like short integer or integer, can include both negative and positive numbers. But when this U comes at the beginning, which stands for unsigned, it means without a sign, so our data is definitely positive. Alright, now we'll get to know each of these separately as we go on. Okay, our next data type is real, which actually relates to decimal numbers. We can divide this one into two parts, real and long real. The any-bit data type, which we said is a logical type, is itself divided into several types. The first is Boolean, the second is byte. The third is word, the fourth is double word, and the fifth is long word. Well, you know that Boolean is either 0 or 1. A byte is actually 8 bits, a word is 16 bits, a double word is 32 bits, and a long word is 64 bits. So, if we want to do something in PLC programming that requires using logical data types, we have to use one of these data types. Alright, the next data type is AnyDate, which itself is divided into three parts. Date, date and time of day, which all relate to calendar dates. Date and time show us both the date and the time, while time of day only shows us the hour. It shows us the time. For example, in a PLC program, you might want to write a program where a motor turns on at a specific date and time, and then turns off at another time. So, we can use these types of data, and they can help us in programming. The next type is anytime, which is a time-type data. If we want to store a time in a PLC program, we need to use the time data type. And finally, there's AnyString, which is a string-type data. If we want to effectively store or perhaps send a complete set of characters within a PLC program, we absolutely need to utilize the string data type. Alright, the very first significant section we will be discussing is indeed about numeric data types. We said that numeric data can be divided into two categories: integer data and data that are actually of the decimal type. So, we say that if we need to perform numerical calculations in our PLC programming, for example, if we want to add two numbers together, multiply two numbers, divide them, or do any other calculation involving numbers in the program, we have to use one of these data types. Short integer is an 8-bit data type that can store values from -128 to 127. The integer data type is 16-bit and can store values from -32,768 to 32,767. Double integer is a 32-bit data type that can store values from -2,147,483,648 to 2,147,483,647. The next data type is long integer, which is 64-bit and can store values from -2 to the power of 63 up to 2 to the power of 63 minus 1. Unsigned short integer is a data type without a sign, which is 8-bit and can store values from 0 to 255. Unsigned integer can store values from 0 up to 65,535. Unsigned double integer can store values from 0 up to 4,294,967,295. An unsigned long integer is a 64-bit data type that can store values from 0 up to 2 to the power of 64 minus 1. So, once again, if we want to do something in PLC programming that requires numeric data, we have to choose one of these data types. For example, if we want to add two numbers together, we define two variables. We set their data type, for example, as integer, and then we can add the two numbers together. Just one thing to note, depending on the number we want to use, we have to choose one of these data types. For example, if our number is between -128 and 127, we can choose the data type short integer. Or, for instance, if we want to do a calculation that only involves positive numbers and is between 0 and 65,000, we can choose unsigned integer. So, depending on what we need in our programming, we choose one of these data types. And if our data isn't an integer, for example, if it's a decimal value, we need to use one of these real or long real data types. Real is a 32-bit data type, and long real is a 64-bit data type. Alright, our next data type is any bit, which, as we said, can be one of the following types. And we mentioned that whenever we need to perform a logical operation, we can use one of these logical data types. The next data type, as we said, is time. Time is a 32-bit data type. If we want to store a time value in our PLC, we can define a variable, set its data type to time, and store the desired time in it. We also explained about any date. We said that it has a type called date, which stores the date for us, and it's a 16-bit data type. There's time of day, which is a 32-bit data type that can store the time for us, and there's also date and time, which is a 64-bit data type that can store both the date and the time for us. Alright, next we'll get more familiar with how to create each of these data types. Now, let's enter the GX5000 software environment. In the GX5000 software, when we want to start programming, the first thing we need to do in this section, in the local variable section, is to click here. The data that we're going to use in programming needs to be defined in this section. Alright, so I select this as a variable. For example, I define a variable called A. I can choose its data type here. For instance, I set its data type to integer. Here, I can assign an address to this variable A that I just defined. For example, mword100. Alright, so now we're familiar with these as well. That is, I want to assign a part of the memory, a section of the memory, to this variable A. For example, I want to assign memory word number 100 from the PLC to this variable A. And here, for instance, I create another variable, let's say, called variable B. For that one too, again, I select its data type as integer. Now here, I can assign it an address. If I give it an address here, whatever address I enter here, my variable B will be stored there. But if I do not enter an address here, the Programmable Logic Controller, PLC, itself will automatically assign a specific part of its internal memory to this particular variable B. So, this type of addressing, where we ourselves assign an address to a variable, is called direct addressing. But this type of addressing where we define a variable and don't assign any address to it, we call it indirect addressing, meaning that the PLC memory itself allocates a part of the memory to this variable. And I define another variable, for example, called t, and I set its data type, for instance, as time. Now, again, I can assign a specific part of the memory to this one as well. Just keep in mind that if we want to assign an address to a time type data, it must be of type MD, because as we said, time uses a 32-bit memory. Alright, now let's assume I've defined these three variables here. Now, let's go into the XG5000 software environment itself. So, as we mentioned in the previous lesson, if we want to use the PLC's built-in functions, if we click on this section, a window will open here where we can use the functions or function blocks. We also said that if we press F10 on the laptop itself, this window will open for us as well. In the previous lesson, we got familiar with the move function, and we said that the move function is one where, if we put some data in its input section, it moves that data. In the output section, we also mentioned that there's an enable part here, which we definitely need to activate. Now, if I click here, it will show us the variables we've created. For example, the first one was variable A. I want to move variable A into variable B and I switch to simulator mode. I activate the XG5000 software simulator here and we'll test this together. Okay, now our simulator is activated. If I click here and enter a number here, for example, 123, I enter it here, for example. We can see that it moved this 123 into variable B. In the previous lesson, we said that the data type we choose for this input section should be the same as the data type we choose for the output section. Since I selected an integer numeric data type here, I also need to select an integer numeric data type for my output section. Now, if I exit the simulator mode, if I now instead of B put a data type of time, you see this part turned red and that means there's an error. That means the software is now giving me an error and says this is wrong because your input section is a numeric data of type integer, so your output section can't be a data of type time. The output definitely has to be of the same type as the input. If I come and fix this, for example, assign B to it, you'll see that the error that appeared here for us is now resolved. So, for any particular type of data that we specifically want to utilize, we have the capability to establish a variable through this designated section. This allows us to meticulously create the precise data we have conceptualized in our minds, which could potentially be one of these various predefined options, and subsequently, we can effectively employ that meticulously crafted data within the comprehensive programming environment. Thank you for your attention.